Good morning, everyone, and welcome to this introduction to InfoDrainage. My name is Randy. I will be going through this, which will mostly be in the form of a software demonstration of a model. A little bit about me and my company. I work for IMAGINiT Technologies. We are the largest platinum partner with Autodesk. We do a lot of Autodesk training, provide Autodesk related services. We have a whole catalog of standard classes as well as custom training options and design assistance available. I am a water resource engineer by trade, so this is my area of expertise. Before working for IMAGINiT, with whom I've been with for about 5 years now, I was a project engineer working on some intensive water resource projects as well as site design. If you came into this class just curious about what InfoDrainage is and you're not quite sure, InfoDrainage is a product that was created by a company called Innovyze, which Autodesk acquired over a year ago. They're now incorporating that into functionality that integrates with Civil 3D. So there is a version now of InfoDrainage that you can get where you can export an entire model into InfoDrainage, where you can do your storm and sanitary hydraulic and hydrology analysis within the tool. Now, I have created the material and I teach classes on storm and sanitary analysis, which is also with Civil 3D. So you might be asking yourself, well, why are we talking about a competing program to storm and sanitary analysis? That is because storm and sanitary analysis only does a fraction of what InfoDrainage is capable of. So for a typical design, you would start out like you normally would. You would have a surface, you would draw a pipe network, and then you would export that pipe network out into some sort of program like SSA, and then you would do your hydraulic analysis from there. And where InfoDrainage differs is when I take elements like ponds or some other storage element inside of SSA, it's just one small object. In InfoDrainage, those objects actually have mass, so once I place in my dimensions, it shows me the dimensions within the software. I can also work in 3 dimensions, which I cannot do in SSA. So you've got a lot more flexibility and a lot more tools to work with when you're actually going through it. Also, SSA will not auto-size pipes for you, whereas InfoDrainage will, based on the results of a rational method analysis. And it can also do 2-dimensional flow, which SSA cannot. SSA is entirely a 1-dimensional flow program, so I can do a 1D, 2D analysis within InfoDrainage. One thing that cannot be overstated is that it also has a focus on green infrastructure. So I have a lot more structure types and conduit types inside of InfoDrainage, like swales and bioretention basins, underground tanks, cellular storage, different ways to model infiltration that in all honesty should have been standard practice up until now, but we didn't really have a software tool to really do those things, so a lot of those calculations have been done by hand. Also, you can incorporate the surface with the model. So I can actually insert the surface in the model. I can have the software determine for me the rim elevations as well as the invert elevations based on the results from a rational method analysis. And I can decide when I'm in the software where to actually place my catch basins based on a 2-dimensional analysis of rainfall over the site. Now you'll notice I didn't even mention the functionality that you get in Civil 3D from HydroFlow because the comparison would be even more unfavorable. HydroFlow doesn't do a fraction of what SSA does. Same thing with the Analyzed Gravity Network tool. If you can get away with using those tools, that's fine. But for anything that requires storage on site or anything that you want to do a 2D analysis for, you're going to need a more powerful tool. So without further ado, let's jump into the software and get started building our model. Okay, so here inside of Civil 3D now, I have a model in which I have delineated these areas around structures for drainage. I have placed in a pipe network. You can see along here. The pipe network is going to flow down here from west to east, and then it's going to terminate into this pond. I also have another pond here that we're going to bring online to to try to take care of some of this, attenuate some of this flow. And then I have another short segment here. Now this is all happens to be one logical pipe network, but it doesn't matter. I could have multiple pipe networks that I export out. And it also has a surface associated with it. So I'm going to take the surface, I'm going to take the pipe network, and I'm going to export all that out into the software. Now you can see, if I say I open up Project Explorer here, and I look along a pipe run from structure 16 to structure 6, which is the longest route right along here that goes and terminates into my pond. You'll see right now that I have I just used the basic Civil 3D template. So the slopes are kind of high right now, between 1 and about 2.5%. So I'm going to actually have to take that, I'm going to reset that in the software. Now I could do that, but of course by setting and running rules. But I can also do that really quickly in one shot because, like I said, when I export this into InfoDrainage, I'm going to be able to take this entire reach right here and I'm going to reset all of the values between a certain slope. It's also going to determine whether or not my first pass guess at my pipes were adequately sized or not. So depending on which version of InfoDrainage you have, you might have the ability to export using the InfoDrainage tab here. Now if you don't, it's not the end of the world. You could go through a few more steps and get it out, but in the most full-featured version of InfoDrainage, it gives you the ability to just export directly to InfoDrainage. So I can go to InfoDrainage, I can tell it which model I want to, I could create a new model here, I can just export it on top of one that I already have and replace it. I can tell it which network do I want to include a surface or not. I can include it. And then it asks me for each one of my pipes, what is the mapping here? Same thing for junctions. So I can set that up. You could have a mapping that's predefined and I could open that and load it. So I could predefine a mapping for each structure type and then I could place it in there and away I go. I'm just going to click finish. That's going to take a second to export all of the things out into my model. And I'm going to open up InfoDrainage. And I'm going to open up that model as soon as it's loaded. So now I've completed the export of my model. So here I am in InfoDrainage now. If you look at the layout, it's very similar to a lot of other programs out there. EPA Swim, SSA, things like that. We have a tree view on the left-hand side where I can get access to all my objects. I also have several panels. So I've got a properties palette, my standard plan view, etc. I'm going to go to File, Open. I'm going to open this model that I just exported. And here I am. So here are my pipes. Now I also asked it to include the surface, which is also included right here. Doesn't look like much right now because it's just a color map. But if I were to look at this model in 3 dimensions, I change to a 3-dimensional view, you can see right here, I have the surface, including all of the details on the grading that I included, and then the pipe network as well. So I'll go back to plan. I'll turn the surface off because I don't really need to see it to use it. And I still need to give myself context as to where I am so that I can work on this design. Now, there's a feature that for those that use SSA, where you could include a background inside of SSA. It could either be a CAD file, it could be an image, but it could only be one. You could only connect to one file. The beauty of this program is I can add any number of things. I could add GIS information as a background. I could add a number of CAD files as a background. All of that is available under import, and I just tell it what type of information I want to grab. So I'll grab a CAD background, and I'll bring in, say, contours. You can tell it which layers you want to include or not include. You could use a different unit of measure. All of these files, they need to be on the same projection. So if you're working in Wisconsin State Plains South feet, you could include a file that is Wisconsin State Plains South meters, but that's about your only other way of projecting because you still need a common datum. We click Finish, and then here you can see it's added some of my information. I could also include, say I have another CAD file out there. I could grab another one, like pond footprints, so I could see those. And then for each one of the individual files, I can turn them on and off as I need to, so that it makes it easier to work. Now, in this exercise, you can set up inlets, and you can go through the process of sizing the inlets and doing bypass flows and all of those things that you might be used to in storm and sanitary analysis. However, just to simplify the analysis, I'm really going to focus only on this main trunk here with the branch along it. And because we're doing a storm analysis, like every other program, the next step I need to go through is creating sub-catchment areas for each one of the individual manholes and assigning some sort of rainfall data to them, or IDF curve. Another nice thing about this program is it gives me several ways that I can accomplish that. So I could come in and say, if I knew what the area was, I could start drawing it in the plan by going to the Build menu, adding an inflow, and then adding a catchment area. I could freehand it, come around and right-click to close. That immediately creates a catchment area. The other thing it does automatically is it automatically routes it into the structure that is enclosed within that area. So rather than having to go through the process of like an SSA where I right click and I tell it to connect to a specific structure, it's automatically going to route to a structure. It might not be the right one. You may have multiple structures in the same catchment area. If that happens, you can do the exact same workflow as you would with SSA where you right click, reconnect the inflow, and then direct it to some other structure. Also, I could use a background file. So I could bring in a CAD file, or I could import, in my case, GIS data like shapefile. And for that shape, I could bring in all of the subcatchments that I have delineated. And I could use those as snappable objects if I wanted to. So I could go through the exact same process, except this time I'll turn snapping on. And perhaps instead of going to the Build menu to grab it, I could use the toolbox because it's even easier to find. Go to the inflows, catchment area, and then as I zoom in here, if I drag and drop, I'll drop it here. And then as I zoom in here, you can see I get a little yellow snapping icon that I can use, and I can snap to the vertices of the object to create my catchment that way. However, because these are already defined as a shapefile, that process becomes redundant. I can remove, so I can clear all of these inflows, and I could just tell it that this subcatchment that I have included is actually an inflow. I can convert it all to inflows. I can tell it the area of it, or excuse me, it'll determine the area of it by the area of the polygon, and again, it'll do the same thing where it routes it to the appropriate structure automatically. If you look at the tree view on the left-hand side now, I have a number of catchment areas, like catchment area 5 here, which I can, just like with SSA or many other programs like it, if I double-click on the icon, will bring up a dialog so that I can change the attributes of that area. You see the area is calculated automatically based on the size of the footprint. I can change the volumetric runoff coefficient. I can change how much impervious area I want, which depending on the method you're using, you might not want to change it at all. give it a default time of concentration, and then set up options here for dynamic sizing. So for the dynamic sizing, when I'm determining the size of the pipes, this is the one set of values, and this has another set of values up here. You can see there's a time of concentration under both. You can actually use a different value, like a more conservative estimate for a time of concentration for dynamic sizing, because you are going to be using the rational method for this, preliminary dynamic sizing. You could say set it at a worst case scenario of 5 minutes to see what would happen to your pipe sizing there. You could also change the method that you're going to use. So whether you want to use a modified rational method, whether you want to use swim. So once I do that, then I have many more options that I need to fill out. Use an SCS curve number method. Give it the curve number. And all of these things can actually be imported when you bring in a shapefile. So the nice thing about shapefiles, because they have so many fields in them, I could have fields set up for all of this information. I could map it ahead of time if I have different values, and all of this would be filled out at the moment I import the data. In our case, I'm going to keep it simple, and I'm just going to use a basic time of concentration method. Now I'm looking at the volumetric coefficient here. And let's say I want to change that for a number of areas. The other beautiful thing about this program is, unlike SSA, where I have to go into each individual area and change this value or copy and paste it from one to the other over and over again, in here I have a section of build tables. Under the build menu and tables, I can pull up a list of all of the inflows and all the properties of the inflows. So I can look at the time of concentration here, or the preliminary time of concentration in my case, and I could isolate that value in the table so that I'm looking just at that value for the table. Same thing with the volumetric runoff coefficient right here, so you can see 0.75. Let's say I want to set that to a very conservative value of 0.9. I can grab the entire range, select it, change it to 0.9, set everything equal to it. And then when I go back into any one of the dialogues or a catchment area, should be able to see that my new coefficient has changed. Speaking of the build table, I can alter any properties that I want for any of the objects. Say for connections here, you can see I have a number of fields here as well. So I can change the Manning's coefficient. I can change the diameter. I can change the number of barrels. All these things can be changed quickly using the build table. So let's say I believe once my pipes converge, right around here, I think the pipes might start to get a bit larger, and then the pipe coming out here, pipe 5, might be larger still. I could make mass changes to an entire reach by telling it which structures I want to start and stop from. That's called a flow path. I could add a flow path and just tell it, say, from structure 16 all the way to structure 6. It's going to determine the path that flow path takes and then create this flow path right here. Something I'll probably want to give a distinct name, so I'll just say it's S16 to S6. This is also something that I can rename and renumber after I have identified it in this way. So let's select this. As soon as I do, under the Edit menu, as I said, I can rename and renumber it. So I'll call this the main trunk. So I'm going to rename this and add a scheme to it by clicking on Rename, Renumber. Renumber all of these, and I'll give this a prefix of MT. and empty C. As soon as I do that, you see right here, it's automatically going to update all of the names right here in the numbers for that entire length of pipe. And because I included the option to rename the branches that came off of it, you can see it's also renamed these secondary lines as well. Now all of this, anything that you see here can be either turned on or turned off. You can see that the text right here is of a particular size. If I want to change that, at any point you can go change any number of visualizations by going to Views and Display Settings. I can open the display settings, and for the plan view I can change the text height to something more reasonable. You see a preview right here. See what 8 looks like. The icons, if the icons are too large, same thing. Change the size of the icons as well. So now that I have this flow path isolated, I can select it, right click, and show profile. So you can see here, I can see a dynamic profile of the surface that I have created. You can see all the rims automatically come up to the surface. And then I have a value in here that is a tracking of the value of the current minimum pipe cover. So you can see none of my pipes right now, well, a couple of them do, seem to breach the minimum pipe cover rule. But the main problem right now is along this line. My pipe network is getting unnecessarily deep because I still have that 1% minimum slope in there. So I'm going to change that based on a 10-year design storm for this area. And I'm going to use the rational method to do so. So like any other program, I have to define my rainfall. I'll go to Rainfall Pollutants, and I will go to the Rainfall Manager, and I will tell it what rainfall that I want. There are a number of ones. The impressive thing is for design storms like NOAA, if I were to add that, it actually goes out, as long as you have a connection to the internet, makes a connection to the NOAA website and then pulls the information back in. So I could get, a full suite of, design storms for it, any number of years that I want for return periods, as well as the temporal distribution for all of it for your area. Just a very impressive set of functionality. In my case, I just want to create an IDF curve. So I'm going to create a new IDF table, and I'm going to just call it 10-year. Well, I'll just call it the areas name. So I've got my South Milwaukee IDF. And I can build it. I can add a bunch of return periods here, or I could load in the file that I've already downloaded from the NOAA website. And I can pull in an entire table from the NOAA website. So now you can see here I have a number of duration storms as well as return periods. All of this that I got directly from the NOAA Atlas for this area. Now that I have that built, now that I have for each one of my catchment areas, I have the preliminary coefficient as well as the preliminary time of concentration I want. I can now use these values and run a preliminary sizing along my network. First, I'll go into the criteria, and I will tell it I'm going to be using this IDF and tell it that my return period is 10 years. After that, in my design options, I can tell it which pipe sizes I'm going to allow it to swap to. I've already built this table, so I'll load it. From here, I'm just going to use concrete pipe. Do I want to level crowns or do I want to level inverts? Do I care for a minimum cover? If so, what is that minimum cover? Am I going to allow drops? If so, what is my maximum allowable drop that I will set? What are my min and max velocities, etc.? I'm also going to limit the pipe's full condition to 80% capacity. And in this case, I'm not going to allow manhole sizing. So now, once I have all of that complete, I just have to run a preliminary sizing for the network using that flow path that I've already created. And if everything goes to plan, when I click finish and run, click next to run it, I should see the updates here in yellow. So you can see the pipe diameter changes that's made, slope changes, invert changes. If I accept these changes by clicking finish, I can then see a report of all the changes made, as well as looking at the profile and seeing that not only did the pipes get significantly larger, but the system became significantly flatter. Now, in the last section where I set up all of the pipe sizing and I did a preliminary sizing, there was also an option to upsize or change the values of the branches as well, which I did. So if I were to add a new flow path, say from here to the interconnect right here, if I were to look at that as a profile, I can see the changes it made along that branch as well. You don't have to do that. You can do it branch by branch. But in this case, because I happen to have this whole interconnected system, now all of these pipes along here have been sized in one click. Now you may notice that unlike some other programs, I do not have anything defined right now as an outfall. The system is smart enough to know that when a pipe flows downhill and then terminates, this must be an outfall. So I can see right here, I could edit the outfall details. Instead of free discharge for this pipe, I could tell it what discharge that I want. So I could have a fixed surcharge elevation, or I can have a variable curve that I set up. It is up to you. Now at this point, I can set up a pond if I wish, and I could draw in some sort of footprint. I could draw in anything that I want. But let's say I want to create a pond, or in my case, I'll set up a bioretention basin. And I'm going to snap to these existing contours because it's going to be at this elevation right here. So I will snap to the contours. And in the interest of time, I'll just bring it around here and close it. And we'll say that is the footprint of the bioretention basin. Now the bioretention basin doesn't have anything to do until it receives some sort of flow. To do that, I'll just build an additional link. And depending on what I want to do, I could set it up as a physical pipe, or I could set it up as no delay. So that would just, basically this manhole would outlet into here. But I'll set up a physical section of pipe from here to here. And then you can see the icon has changed, letting me know that this is now an inlet into this system. I can do the exact same thing over here, so that now this section here is then set up as an inlet in here. And I could also set it up so that the area, the catchment area right here, instead of draining to this point, I could then drain it to the bioretention basin as a brand new inlet location. And I could set all of those locations up to tell it whether or not the flow is a point flow or it flows as a lateral flow which would load it all the way around the boundary. Now, this is an important step before I do anything else, because when I go into the settings of the bioretention basin itself, it's going to have some values that it thinks I want for the exceedance level, the base elevation, and things like that. So you can see I've got my base is at 672. I'm not quite sure what the exceedance is going to be, nor am I sure what the side slope is going to be right now. So I could change any values that I want in here, and then I could set the radio button over these so that it calculates the value for me. And it does that by using the sizing calculator right here. In the sizing calculator, I can do a quick storage estimate up to a certain amount, which I could say is set up to the freeboard, which I've set here. And I could tell it what volume I want to use and what I want to change. So do I want to change the area? Do I want to change the base? Do I want to change the depth? Let's change the area or the footprint. And then I'll go to the quick storage estimate. And based on the values I put in here, what assumed discharge rate I'd have from my pond, what infiltration I'd have into the soils of the pond, I could calculate it and come up with a value for the volume that it needs. However, I have not set up the design storm yet. So instead, I'm just going to set this up as 80,000 cubic feet. I'll click OK. It has then updated my values for my area. Click Apply. And then it shows me this new reduced footprint based on the values that I've given it. Now at this point, I'm going to jump forward in time. I'm going to open up a model that has additional configuration, and I'm going to talk from that model. And from here now you can see an example of my completed model. You can still see the pond, although after the change is made, I have considerably larger area. All of the green areas, again, are sub-basins. All these orange areas are some sort of pond or structure. So you can see I have a number of them now. And I've taken advantage of the natural terrain and placed in, instead of using traditional pipes, placed in swales. Here's a dry swale that has an underdrain in it. I have a standard pond here, as well as a bioretention basin here. Now this is a fully fleshed out model, but the nice thing about InfoDrainage is you can track your progress and go back to a previous phase of design. So if I expand phase management, you can see I can do both storm or sanitary models. And I have a number of phases right here that I've gone through as I was creating the model. If I change, say, to the first phase and make that current, and I turn this on and then turn this off, the current phase, when I run it, you can see what it's actually going to run. Everything that is kind of pops in color is everything that is current in this model, as well as everything that is muted is something that exists in that phase that doesn't exist in this phase. So you can turn on any number of changes in phases. So you can see here in this phase, it looks like as where I added the swale and made some changes to geometry. So you can go back at any point and actually have one model. We have multiple design scenarios as well as a progression of how you did the design in the first place. Let's change back to the current scenario. And I will turn off all other scenarios, as well as any changes in geometry from those scenarios. Now, I have everything configured. I have a number of flow paths set up, so you could see not only along the main trunk, but you could see along other lines. I've set up a number of swales as well as a pond here that I can see in profile, with a number of check dams set in between to fill up each one of these areas and take advantage of infiltration to limit the footprint needed for my pond. I have pipes, I have triangular channels, you name it. If you look at the stormwater controls here, you can see this is where the software really shines, is just the sheer number of different structure types that I have. Each one of these structure types has pre-configured values into it, which makes sense in the context of the object it is, like porous pavings, or whether you have an infiltration trench, or a regular swale versus a dry swale, things like that. Before, in traditional piece of software, all of these are set up as storage nodes, and then you'd have to do some mathematical magic to try to get it to work the way it actually operates in the field. Now you don't. This takes a lot of the guesswork out of those green infrastructure type objects. Now let's run an unsteady state model, and we'll look at the results from those. Go to the Analyze window, and go to the Analysis criteria. I've set up a number of storms here. I've set up an average storm for the 100-year. I've also set up any number of storms. You can actually see the sheer number of storms when you click on it based on what you have. So this one scenario right here is going to look at 720 different storm permutations to see which one would be worst case scenario. I don't have to filter through all of those. I don't have to run a report for all of those. When I get done, and I'll pick a shorter one for the interest of time that just runs 16. When I run that, and I look at the results, I can only look at the critical storm if I want to. So I can see the worst case scenario up front. There's also a validation button to let you know if you have any issues, any warnings. Looks like I have a catchment area that's not connected yet. I'll ignore that for now. I'll click Go and run the analysis, and it speeds through it. It goes through it rather quickly. So again, I'm running 16 storms unsteady state, but it still goes pretty fast. But still, I'll pause here and we will review the results. Okay, my run is complete. And now I'm looking at the 6-hour storm here for my 100-year. And it tells me right here for this particular storm what percentage of each one of my structures right now is available, as well as the status. Did I flood? Were there any things that are in risk of flooding? Are there any issues with my system? That type of thing. Now, I could search through all of the areas and all of the storms. There's no need to do that because I can click on the critical storm button for all items, and it will automatically show me the worst case scenario for each. So you can see, based on the geometry that I have, some of the objects would be in a worse off position for the 6-hour storm. Others would be in a worse off position for a 96-hour storm. And one, looks like worst case scenario, would have an issue with the 12-hour storm. All of these are the exact same return period, just different duration storms. So instead of having to run all of these storm events one by one, I've run 16 different average 100-year storms for different durations. And I found that in one case, if I expand this, looks like my bioretention basin is a flood risk with only 5% available volume left if I were to run a 96-hour storm. Same thing occurs if I were to look at the results tab for all of my junctions or connections. See here, for the 6-hour storm, everything looks okay. I have some minor surcharging in some areas. If I were to look at the critical storm, and again expand this, same thing. It looks like for the most part the 6-hour storm would be the worst case scenario, which is to be expected in this case. If that is not enough information for you, you can also look at inflows for any of the connections or stormwater flows, any of the structures that you can think of in here. So I can see what my hydrograph is going to look like for rainfall versus flow. Same thing with the stormwater controls. For my bioretention basin, I can see here a graphical representation of my depth versus time and things like that. You can see this in graphical as well as tabular form. And if that's not enough for you, you could look at a 3D representation of the object, tell it which storm event you wish to see, and then run an animation over time. So let's speed it up. You can see at 125 hours, I've got considerably more volume than at 60. And then by the end of the storm, you can see why I only have 5% of my available capacity remaining when I take into account the 1 foot of freeboard. Now, as far as the remaining reports, you can run a comparison between the different phases or different design scenarios. So you can set this all up. You can have any number of reports that you'd predefine in here. So I can tell it which fields I want to show. The page width, you could set everything up, and then you could set up the reports that way. I could show a report on the manhole schedule. You can see right here. I can also show a takeoff report. Here's for all of my structures, my earthwork. There's an audit report, you name it. And last but not least, you can run a few different two-dimensional analyses. So I could run a full 1D, 2D analysis on this, or I could do a simple deluge analysis where I drop a certain amount of rainfall over the area, and you can see right here by my depth where everything is going to accumulate. So you could do this before you set any structures up, and I could place structures in the low points where I know that there's going to be accumulation, like here and here, here. Obviously, everything's going to accumulate down in my pond. So it's one, a sanity check, and two, a good pre-detailed design analysis where you could actually use this to place either inlets or other structures. And maybe one last visualization just for fun. Now that I've run a 2D analysis on it, 1D, 2D analysis, I can see the results both on here if I were to set up the visualization, or I can see the results of my 2D analysis over time in a 3-dimensional view. So maybe I'll go ahead in time, maybe start somewhere around hour 22, and you can see here water is flowing into my pond, into my bioretention basin through my swale. If I zoom in, you can see it's actually going through the conduits as well as through my dry swale down here.